All right, so today I'm not going to make a whole program in Python, but I am going to look at variables, scope, data types, and maybe help explain some of the things that a few people are stuck on. So first we're going to look at variables. Now, making a variable in Python is super straightforward, which is really nice. All you do is give it a name and then assign it to something. So here I could say that the variable x is going to be equal to the word hello. Now, a variable is basically just like a box that we have named x in this case, and anything I put in that box is what that variable represents. So if then I go down and I ask it to print x, then when I run this, it is going to print hello. If I want not to be a word, maybe I'm going to be a number, I'll be the number 7. So now x is 7, and so when I print x, I print the number 7. This is true for a number of different data types. It also doesn't have to have a name like x. It can have a longer name like my variable. And as long as I'm consistent, I can name it pretty much anything I want. There are a few reserved keywords in Python, but if you accidentally name it one of those, it will just, in most of your environments, including this one, change its color so you know that that is not a variable name you can use. Okay, so now I have changed the name to my variable. It's still the number 7. So I'm going to clear it out so we can see it. And now if I run the code, it prints the number 7. There are also several different types available in Python. And so there is a built-in function that will tell you what type you're dealing with. So type is the name of the function that I'm going to run here, and it is going to print out what type of variable my variable is. So in this case, it's an int for integer. If I make it a decimal, we'll get float for floating point. That point can move around in the number, right? If we give it some text, that's called a string. STR is for string. We can also be just, if we spell it correctly, just true or false, and that will get you bool for Boolean. So true, false, yes, no, that's all there is between it, right? True, false. And those are not the only options, but those are kind of the ones that I expect you will use the most. Perhaps some of you might need a list, and that would look more like this. So this is a list divided up by commas of 3 different things, a list. If we go back to just print it, it prints the whole thing. You will probably get to lists a little later. You might not need them yet, so I don't want you to worry about lists right now. We'll go back to this being a number. Okay, so all you have to do is give it a name. You don't have to tell it exactly what type you will be using. It will figure that out on its own, whatever it thinks is kind of the most appropriate, and treat it in that way. Sometimes you might need to switch between variable types without changing the content. So let me show you why we might want to do that. If I have the number 7, for example, I might want to be able to add something to it. So 7 plus 5, and then when I print that out, there we go. 7 plus 5 is 12, so it prints that out just fine. It could tell that this was a number. It automatically decided that it was an integer, if you remember from us checking the type, and so it had no problem adding 5 to it, okay? But if I wanted to print out a string, like my number is, we'll see what happens. It should, right? We're thinking, oh, it successfully printed the number 7 before, it successfully printed text before. I know the plus sign is how I put those together, so this should work out just fine. But in fact, it makes Python very unhappy. Python only wants to put strings together, strings with other strings. And as far as it can tell right now, my variable is not a string, it's an integer. So what we have to do, that yellow bar bothers me. There we go. What we have to do is we have to say, hey, I know the number 7 is a number, and you know the number 7 is a number, but I would like you to now treat it as a string so that I can do things like print it out. Okay, so that string, right, and then parentheses, that changes the data type just for this instance. It doesn't go back and change up here. Changes down here temporarily your data type so that it can use it in this print statement. Okay, another option would be to change it up here. So now if I run this guy, up here I made it a string. And so when it comes down into this print line, my variable is already a string. And so it has no problem putting it together with my number is. However, if I then try to use it in an equation like this one, we're gonna see what happens. Oh, nope, can't do that. Because I said that I want the number 7 to be treated like a string, and you can't add numbers to strings. That just doesn't work out. In the same way that you can't do grapes plus 5, you can't do 7 plus 5. So the only way to keep going with this one is to try and change it back into an integer again, and then it works out. Okay? So you can change it in either place. In most cases, I would say that if you, clean this guy back up. In most cases, I would say that if you have a number, you mostly want it to stay a number until you want to print it. And if you have words, you want them to stay words. So most of the time I would recommend leaving your variable in the type that it thinks it is, and then only changing its type as needed instead of way back at your variable. Hopefully that makes sense. Okay, sometimes this can go wrong. So let's take a look. What if my variable goes to be a word? We're going to make it purple. That's my favorite color. Purple. My variable is purple. So I can print this out. No problem. But maybe I want to add 5 to it like I did a minute ago. Well, I know that all I have to do is change this into an integer, right? Oh, nope, see, that doesn't work. I can't change purple into an integer because it is a word. You can't add 5 to purple and come up with anything that actually makes sense. So that is going to throw an error. That's what that yellow line means, is that we have an error. Here in our output area, you can see the type of error. It is a value error. Value error. So what I'm going to show you is something called try and accept. So this is a way to attempt something in your program, but have a backup option if it doesn't work out. Okay, so now I have purple as my variable. I'm going to try and add 5 to it and print that out. But if I get some sort of error instead, I'm going to print there was an error. And indeed, there was an error because you can't add 5 to purple. But if I go back and change my variable to the number 7, then we get 12. So it tried to turn my variable into an integer. It was successful. So it added 5 and printed that out. And the except line never executed because we didn't have an error. Okay, so that is a really useful structure to use in Python, that try except. It's a really good way to check user input, for example, and make sure that it's the type of user input that you want. So if I go up here and I was asking for input and I said, please type in a whole number. And I could say, print out that was not a whole number if they did it wrong. So down here, input is going to ask for input from your user. It's going to try and treat it as an integer. And if they type in something that can be treated as an integer or converted to an integer, it will. But if it gets an exception, it will throw an error. And because it throws an error, it will let the user know that there's a problem. So let's try that again. Please type in a whole number. So let's do it right. Number 7, we get 12. Excellent. Type in a whole number. So I'm going to try 3.4. And it says that was not a whole number, which is true, right? It was a number, but not a whole number, not an integer. Okay. And I will say hi. And that was also not a whole number. Okay, when we look at the except part, we can break this out even more particularly and say we only want to look at value errors, like the one we got when we were typing in the wrong type. There are a whole lot of different types of errors, and so if you want to limit it to only certain types of errors, you can do that just by telling it what kind of error to look for in that except line. And you can do multiples if you want to look at multiple different types of errors, but if you just want to do all errors, except will work. Okay, so try and except, that was useful. Let's talk, so that was a little bit about variables, a little bit about types, a little bit about the try. I also want to talk about scope. I'm going to change this back to an X, not because there's anything wrong with calling something my variable, but I expect to be typing it a bunch of times, and so for this I want something shorter. Okay, so I can print X. I'm gonna make it a number for right now. We'll make it 150. That works just fine. I can also change what X is. So now X is gonna be 20. And I'll print again. So at first it's 150. I change what it is, I print it out again, and it prints out the new value. We also have functions. If you haven't got to functions yet, that's okay. I'm going to show you the really brief structure for what a function looks like. You say DEF for define, and we're going to make a new function. So my function. Really clever name. It gets parentheses. For now, they're blank. If we get to a function where you want to be able to pass in information, that's what will go inside the parentheses. But when you're starting out, they're probably blank. On a new line, it automatically has a tab at the beginning of that line because that's how we'll know what is in my function and not in my function. Right underneath that define line, anything that's indented is part of that function. When I take away the indenting, Python will know that my function is done, and that's all I want to be in there. So I'm going to, I'm going to start with just a print x, and we'll see what happens. So this very first time, nothing at all is going to happen. I'm going to turn this one off. So it successfully ran my code, but we got absolutely nothing over here. So why is that? It's because I have defined a function. I set up something for it to do, but I didn't let it actually run. If you want your function to run, that goes somewhere down below it. And it looks like this. We're now calling my function and say, hey, this thing that I set up to use, I'd like to actually use it now. Okay. So now, if we try and run this, we get 150. Okay. So it went and looked for x and found that it should be 150. If I change this value and we run it, we get a new value. Okay, so now I'm going to let this one print out here, and then I'm going to have a new x that will print inside my function. And we'll see what that looks like. So up here, I assigned x to be 200, and I printed it out, and that's where we got the 200. And then inside this function, I made a new x. I know it looks like the same x, but it's not a new x. And I will do another print down here so you can see that better. This new x is high. And so it prints out high. Now if I go back down here and I say print x again, you can see that that x is still 200. What? So this is what we mean when we're talking about scope. This x that's inside the function only exists inside that function unless I do something in the function to hand it back out again. So for right now, this x and this x are totally different. This is terrible form. Please don't do this. Because it can be really, really hard to tell just by looking through someone's program, which x are we talking about at any given time, especially if you start handing it back out of the function again. Don't do that. Change the name of this one inside. Make it y. Or anything else. You'll see that we get the same result. Okay, so now this one is x, and it's 200, and I'm going to print it out. And then inside the function, there's this other variable called y, and I will print it out as well. And then I'll go back to printing x, just to prove that it's still unchanged. Okay, so if you want to change the value of this one, fine, we can look at how to do that. But if you want to just use something within your function, please, please, please give it a new name. Scope can be confusing enough for most people. You don't need to make it worse by using the same variable names over and over again, okay? You can make up something new as often as you need to. All right, so that was types, variables, try and accept, and a little bit about scope and function. It's probably enough for today. If you have other questions about type, scope, anything like that, you can let me know. Hopefully this helps in completing your Python programs.